if I'm a Cochrane author and I've done my analysis and I've followed all the guidelines, and my prediction interval, I choose to show a prediction interval, and it's quite a bit wider than a confidence interval. How would I kind of interpret that as an author? Kind of what would I sort of conclude from that and say, I think is my question.
Well, it's telling you about the dispersion of true underlying intervention effects. So it's helpful in it's helpful in kind of quantifying that heterogeneity. So if it's the case, for example, that you end up with an effect estimate and its confidence interval that all sits on one side of the null hypothesis, but when you actually calculate your prediction interval and it ranges from potential benefit to potential harm, then what it's saying that on average the intervention might look to be beneficial, but in any particular setting, if you rolled out that intervention, it could range from being harmful to beneficial. And that should kind of come into your certainty assessment. It's a really important finding. We can't just be interpreting what the average effect is. We have to kind of think about that distribution of intervention effects when we are fitting a random effects model. That's equally as an important component as it is in calculating that average effect. So it's really critical for interpretation. I don't know if Archie wants to add to that.
Yeah, exactly. I fully agree. And I would probably also say that this big change, let's say, between the prediction interval and the confidence interval would actually show that we have high heterogeneity in our data set, right? So that's exactly what Joe explained.
Okay, thank you both. Okay, so we have got some questions popping up now. Thank you, everybody. So first question from Nathan. So I'm not entirely sure I understand this question. Maybe you two will better than me. He's written REML meta regression question mark. If that makes sense to you.
I believe this refers to the restricted maximum likelihood and whether RevMan is able to perform a meta-regression using this. But I don't think we have this option yet in RevMan, and I'm not sure if there are any future or, I mean, close future decisions on this. So I don't know, Joe, if you want to add something here.
Yeah, it's not implemented in RevMan meta regression. I think most software packages seem to use REML as the default in meta regression.
Okay, thank you. Question from Charles. If we need at least 10 studies to calculate a prediction interval, shouldn't that same criterion be applied to the estimation of tau squared?
So you want me to reply that, Joe?
Yeah, happy for you to.
Absolutely. So the more studies, the better. I fully agree. It is really, I know it's a really restriction in mainly in most of the Cochrane reviews that we don't have enough studies to estimate heterogeneity. But this is the case, and I would agree. We need many studies to estimate accurately heterogeneity, and that's why we actually we said that we need this uncertainty around this estimation, the confidence interval, to present this so that we see, let's say, how uncertain this estimation is. So if we have, let's say, 5 or more studies, we would recommend to use the 95% confidence interval to calculate this uncertainty around this tau square.
Great, thanks, Archie. A question from Louis. I'm about to submit a review to the Central Editorial Service. We use the default methods available up to now. Do we need to update the analyses and highlight the differences between the protocol and the review? I can also comment on that if you want, Archie, but I'll let you.
Absolutely.
I would say you don't need to, because obviously you've constructed all your analyses, with the methods that were there at the time. I would probably say don't hold up submitting your review if you're about to submit. If if you have a little bit of time and you do want to update, then do, as long as you clearly explain what you've done in your differences. But you don't need to, I guess, is the message, because obviously these have just come in, and these are very new for people, and you've gone so far with the old methods, kind of thing, if that makes sense. If you'd agree with that, Archie?
I would agree. Yes. Thank you, Rachel.
Brilliant. Sounds like two papers there. Yeah, well, yeah, there's always, publish as much as possible, I always say. Thank you, Benjamin. Okay, a question from Christina. I'm wondering thank you for the presentation, can we apply these methods to diagnostic test accuracy? Is a question from Christina.
So this is a great question. So all these methods so far, we focus on the intervention reviews, but for the diagnostic test accuracy, we need to consider two affect sizes. We need specificity and sensitivity. So this would need to be, I guess, extended to account for the bivariate models, I guess. So the way that these formulas appear now are for intervention reviews, I think, not for the DA yet. So that's what I believe. And of course, any more comments are more than welcome on that.
Thank you. A question from Youssef. So if both Hartman and Wald are reported, which prediction interval should we discuss?
I think it was the case if you were presenting both, then you're probably not going to be in a position to be presenting a prediction interval. Because the reason you often present both is because they are strongly in disagreement. And that generally comes about because you've got few studies. So I don't think it's a scenario that's likely to arise.
Thank you. A question from Waldemar. I hope I pronounced that right. And they're wondering if there are scenarios where we would prefer Desmonian and Laird over RevMan. And if there aren't, should we completely get rid of Desmonian and Laird as an option for authors?
I think there is one of the original reasons for maintaining Desmonian Laird is that it is possible that you can have non-convergence with RevMan, so you just don't get an estimate. But in fact, when we applied these as part of the kind of decisions around what methods to implement, we actually applied all of these methods to thousands of meta-analyses within the Cochrane Library. And I don't think we had one example of non-convergence because we kind of tweaked the settings so the RevMan team tweaked the settings so that wouldn't happen. So the reason for maintaining it really, I think the main reason for maintaining it is really historical in that there are reviews that have used Desmonian Laird. In many ways also the decision around, we know that Desmonian Laird tends to underestimate the heterogeneity variance, but really the big impact comes about in the confidence interval method more so than the heterogeneity estimator selected. So I don't think there's an issue with maintaining that estimator there for historical reasons and for the potential chance of non-convergence in the 1 in, I don't know, 30,000 review meta-analyses. I don't know. You might have something to add.
No, exactly. I fully agree, John.
Thank you. Okay, so I think we've got a comment rather than a question from Charles. Again, the option to test for subgroup differences is a step towards meta-regression. I don't know if you have any comments to make on that observation.
Nothing to add from me.
Okay. And a final question from Sivan. So in a same review, they have multiple meta-analyses. And can we use the two methods, wild type or HKSJ, in the same review, depending on the number of studies in the meta-analysis?
If I understand the question correctly, within the same review, you're likely to end up using the different confidence interval methods, because it's dependent, if you follow the recommendations, because it's dependent on the number of effects that are included in the meta-analysis and whether you estimate whether there's heterogeneity in a particular meta-analysis or not. So yes, it is likely that you would end up using those different methods, and it might, I guess, seem inconsistent, but what we're trying to do with these changes is for any particular meta-analysis really get the kind of best confidence interval that we can for that particular meta-analysis, and that's why you could be directed to use a different method.